Pluto, once a recognized planet in our solar system, is a distant and enigmatic dwarf planet. Recent alarming statements from leading astrophysicists, Neil deGrasse Tyson and MIT's Michio Kaku, have thrust Pluto back into the limelight with a startling revelation: this icy world might be on a collision course with Neptune. But how could this scenario unfold, and what would the ramifications of such a colossal event be? Are we observing a rare astronomical phenomenon, or is there something more to this potential cosmic collision? Let's delve into the possibilities surrounding a Pluto-Neptune impact. Pluto, demoted from planet status due to its unusual orbit, continues to intrigue and captivate astronomers. Recent forecasts by top scientists suggest that Pluto's trajectory is alarmingly close to Neptune's. Leading astrophysicists like Tyson and Kaku have raised concerns about a possible dangerous collision between these two celestial bodies, which could pose a significant threat to Earth. But how is such an event feasible? Pluto's orbit around the Sun is unlike any other planet in our solar system. It takes an extraordinary 248 years to complete a single orbit, meaning it hasn't finished even one full revolution since its discovery in 1930. The peculiarities don't end there. Pluto's orbit is highly elliptical, diverging significantly from the nearly circular orbits of the major planets. Additionally, Pluto's orbit is tilted at 17 degrees to the ecliptic plane, making its path much steeper compared to other planets. These factors contribute to the complexity of its orbital pattern. One of the most fascinating aspects of Pluto's orbit is its intersection with Neptune's path. For approximately 20 years in each orbit, Pluto actually comes closer to the Sun than Neptune, defying expectations based on their positions in the solar system. This raises the natural question: why hasn't Pluto collided with Neptune? The answer lies in the gravitational influences of other planets. Shortly after Pluto's discovery, astronomers began studying its orbit, struggling to understand its unique trajectory. Unlike other planets with orbits close to the ecliptic plane, Pluto's steep inclination and elliptical shape stood out. The realization that Pluto's orbit crosses Neptune's added to the mystery. The stability of Pluto's orbit amidst these complexities underscores the intricate nature of space mechanics. The three-body problem, a fundamental issue in celestial mechanics, involves understanding how three bodies in space, like Pluto, Neptune, and the Sun, interact through their gravitational forces. It's akin to predicting their movements based on their starting points and mutual gravitational pulls. For Pluto, this problem illustrates how its orbit, Neptune's orbit, and the Sun's gravity interact in a complex manner. Terms like armal libration, latitude libration, and VZK oscillation are part of this intricate puzzle. Armal libration refers to the fact that whenever Pluto crosses Neptune's orbit, it is at least 90 degrees away from Neptune. This spatial separation is crucial in preventing collisions. Latitude libration pertains to the vertical movement of a celestial body in its orbit, which means that when Pluto approaches Neptune or any other giant planet, it is positioned significantly above their orbital plane, adding another layer of protection against collisions. Another essential factor is the VZK oscillation, named after scientists von Zipper, Leff, and Kai, who studied the gravitational interactions between space objects. This oscillation explains why Pluto's path around the Sun is so unusual. Despite Pluto's seemingly erratic orbit, this oscillation helps maintain its stability over long periods. These phenomena work together to keep Pluto's orbit stable, ensuring it doesn't collide with Neptune or get deflected from its course. Understanding the three-body problem and these gravitational interactions helps us learn about Pluto, our solar system, and distant celestial bodies. Numerical simulations from the late 1980s revealed that despite the apparent stability, Pluto's orbit is technically chaotic, with small deviations in initial conditions leading to significant long-term changes. However, Pluto's unique orbital properties have been found to maintain stability over incredibly long timescales, effectively keeping chaos at bay. Recent computer simulations have clarified how major planets like Neptune, Jupiter, and Saturn influence Pluto's path around the Sun. Neptune's orbital connection with Pluto, where Pluto completes 2 orbits for every 3 of Neptune's, helps stabilize Pluto's trajectory. Jupiter's gravity also plays a significant role in maintaining Pluto's orbit, with Saturn contributing as well. These findings highlight the importance of understanding the complex dynamics of celestial bodies to maintain order and predictability in the universe. Without these mechanisms, the solar system could experience much greater chaos and unpredictability. Pluto's case underscores how even seemingly unstable orbits can achieve equilibrium through gravitational interactions and orbital mechanics. Continuous observation and study of these phenomena are crucial for grasping our place in the cosmos and navigating the unpredictable nature of celestial bodies. Pluto, an enigmatic and distant dwarf planet, was once classified as a member of our solar system's planetary ensemble. However, recent surprising revelations from leading astrophysicists, Neil deGrasse Tyson and Michio Kaku from MIT, have thrust Pluto back into the limelight with a startling claim: it may be on a collision course with Neptune. This raises significant questions about the likelihood and implications of such an event. Are we witnessing a rare astronomical occurrence, or is there more to this potential cosmic clash? Let's delve into the potential consequences of a Pluto-Neptune collision. Pluto's orbit, which led to its reclassification from planet to dwarf planet, continues to intrigue astronomers. Current predictions from top scientists suggest that Pluto's path is perilously close to that of Neptune. Leading astrophysicists Tyson and Kaku have issued warnings about a possible catastrophic collision between these two celestial bodies, which could pose a severe threat to Earth. But how is this possibility even conceivable? Pluto's orbital journey around the Sun is unlike any other planet in our solar system. It takes an astounding 248 years to complete one orbit, meaning that since its discovery in 1930, it has not finished a single full revolution. The intrigue extends beyond this. Pluto's orbit is highly elliptical, deviating sharply from the nearly circular orbits of the major planets. Furthermore, Pluto's orbit is tilted at an angle of 17 degrees relative to the ecliptic plane, making its trajectory much steeper compared to the other planets. These characteristics add layers of complexity to its orbital behavior. One of the most intriguing features of Pluto's orbit is its intersection with Neptune's path. For about 20 years of each orbit, Pluto actually comes closer to the Sun than Neptune, contrary to what one might expect from their positions in the solar system. This naturally leads to the question: why hasn't Pluto collided with Neptune? The answer involves the gravitational influence of other planets. After Pluto's discovery, astronomers began to study its unique trajectory, initially struggling to comprehend its unusual path. Unlike other planets, whose orbits are relatively close to the ecliptic plane, Pluto's orbit stands out due to its steep inclination and elliptical shape. The realization that Pluto's orbit crosses Neptune's path added to the mystery. The stability of Pluto's orbit amidst these complexities demonstrates the intricacies of celestial mechanics. The three-body problem in celestial mechanics is concerned with predicting the motions of three celestial bodies, such as Pluto, Neptune, and the Sun, under their mutual gravitational influences. It's akin to forecasting their future positions based on their initial locations and gravitational interactions. In the case of Pluto, this problem illustrates how its orbit, Neptune's orbit, and the Sun's gravity interact in a complex manner. Terms like armal libration, latitude libration, and VZK oscillation are crucial to understanding this interaction. Armal libration refers to the phenomenon where Pluto, when crossing Neptune's orbit,